Today we finally defined the power rule for all exponents that are real numbers, not just x squared and x cubed. So we said if f of x equals a times x to the n, a is just some coefficient, n is just some real number exponent, then the derivative f prime x is equal to n times a times x to the n minus 1. In words, what we're saying is we take the exponent and multiply it by the coefficient, and then we drop the coefficient down by 1. So for an example, here we have 3.5x squared plus 2x minus 7. So the idea here is that we're going to take 2 and multiply it by 3.5. So f prime x is equal to 3.5 times 2 is 7, x to the first power plus. So when we're taking a derivative of a polynomial like this, we can just take the derivative of each piece separately. So now we need to do the derivative of 2x. So there's a couple ways of thinking about this. 2x is just a linear piece, it's just a line, and the slope of 2x is just always going to be 2. So when you're taking a derivative of a linear piece, it's always just going to be whatever the coefficient is plus 2. But how this connects to the power rule is if we have 2x to the first power, right, to the first power, well, we multiply 1 by 2, and then we drop our exponent down by 1. So 1 times 2 is 2x, and then 1 minus 1 is 0, right? So it's 2x to the 0 power. X to the 0 power is just 1, so that leaves us with just 2. Okay, so the derivative of 2x is just 2. And then the derivative of a constant is always going to be 0, and again, there's two ways to think about this. So a constant piece has no slope, it's not changing, it's always just equal to negative 7. So because it has no slope, the derivative is 0. But how it connects to the power rule is if we say we have negative 7 times x to the 0 power, right? Well, multiply by the exponent. We have 0 times negative 7 times x. Technically, it's going to be to the negative 1, but it doesn't matter because we're multiplying by 0. So the derivative is just equal to 0. So our final answer for this is just 7x plus 2. We don't have to write minus 0. Let me do one more example. 5x to the fourth plus 2x cubed minus 7x plus 2. I want to define a function that will tell me the slope of that function at any given x value. So I apply the power rule to each piece. So 5x to the fourth, derivative of that is 20x cubed plus 2x cubed is going to derive as 6x squared minus 7 plus 0, because the derivative of a constant 0. So here is our derivative, 20x cubed plus 6x squared minus 7.